guys to my YouTube channel. In this video we're gonna look on how to calculate the output power transmitted by the drive if they were given the efficiency, right? So I've given example 5 there. Read as follow: the coefficient of friction between the driving pulley and the flat belt is that the coefficient of friction is 0.31 and the belt width is 130 millimeter. The driving pulley, right, the driving pulley diameter is 740 millimeter, and its speed we have given there is rests per minute. The belt thickness is 5.5 millimeter, and the maximum allowable tension exerted on the belt must not exceed 2.75 newton per meter width. Check per meter width, not per meter plier, but per meter width. Take note there. And they say if the density of the material is that, and the angle of wrap between the belt and driving pulley is this 160, they said we should calculate the output power transmitted by the drive if the efficiency is 75%. This is what we're supposed to use, right? Okay, so by the way, I can collect data quickly. So I may grab data very quickly. I can say there, let us collect the data very quickly. What I remember, it was the coefficient of friction is 31. What else? The width is 130 millimeter. The diameter of the pool is 170, and the speed is 725. Okay. The diameter of the pulley is 140 or 740. Then it was 725 rests per min, right? Then what else? Thickness is 5.5, and the allowable tension is 2.75 newton per meter. Thickness is 7.5 millimeter. And we have the allowable tension there. We have given the allowable tension, isn't it? We've given the allowable tension, which is what? Yes, 2.75 newtons per meter, which is 2.75 newton per watt millimeter width. So what else do we have? The density 1,3 times 10 power of 3 is fine. Density, no, this is in kg per cubic. What else? The angle of wrap is 160. What else? Now we've given the efficiency, which is 75%. Now we can calculate the output power transmitted by the drive if the efficiency is this. So how can we go about this? How can we go about this? How can we go about this? How can we? Can you go about this? Want the output power. Okay, it's fine. Let's go. Let's check what do we have. All I know, the power must have a what, a velocity. Then the power must have tension 1 and T2. For now, all of that I know. Always the power must have T1 and T2. And also, depending on what we want, which formula we will use. So okay, I can calculate the velocity. What I know for now is that power must always will have a velocity, but now because we have given a thickness, will be plus T multiplied by what, by that. This will be the velocity. Then this will be pi, the diameter. There we have given the 740 divided by 1000 will be 0.74 plus the thickness, which is the thickness is 5.5. If we divide 5.5 by the 1000, there would be 0.0055 multiplied by the speed, whereby here it is we have that there 725. Then divide this by 60. Yeah, I'll try and punch this. If you punch that on your calculator, therefore the velocity okay, 28.3 meters per second. So yeah, we have the velocity. Right, we have the velocity. Now check that velocity. If something that we've discussed, I've said to you, if you know my introduction, I said if our velocity is greater than 10 meters per second, we always must consider TC, the centrifugal force. If it's greater than that 10 meters per second, if your velocity is bigger than this value, consider the TC, centrifugal force, please. Right, so we'll consider it. We know that TC is equal to mass multiplied by velocity we have, but now the mass we don't have, so the mass is the one that we're supposed to have. The mass is volume multiplied by density. Now we know the formula I've been explaining will be area, which is width multiplied by thickness. Then to become volume, we'll multiply by L. So this is volume now, and then multiply by this will be density. So we'll multiply this by density. Now we have our mass. So the length, I said always take it as 1 as per meter. So the width, we know we have calculated, we have our width, we are given this 130, you divide by 1000. This will be 0, 0.3 multiplied by the thickness, which is was 5.5, and then you divide by 1000 will be 0.055. The length will say must be 1, always use 1, please. Then density is 1.3. I still remember these terms, 10 to the power of what, 3. Then the mass 0.93 kgs per meter. Remember, we've used what, 1 there, per. Our length is per, is 1, is per meter there. Remember, our length, we're supposed to always, when you substitute, use length 1 meter there. Right. So that we have. Now we can calculate TC with mass multiplied by V squared. We know that we have 0.93. the velocity we've just calculated is 28,3 squared, then TC. What will be TC? If we punch this, we will receive TC as 744,8 Newton. That is what we have. So we have TC now, but remember the power must have always, remember the basic formula for power is this T1 minus T2 that we know multiplied by velocity. We must have T1 and T2, but now we have centrifugal force. We'll adjust, we'll see which one we'll use the formula, but all I know, the power must always have T1 and T2. So let us try and calculate T1. I want T1 in this question, guys, will is the touch side. I write the touch side in this question because we've given a width and thickness, and when we have given the allowable tension, this is the formula we're supposed to use. This is what we use, guys, right? So you have the width, we have calculated, we've been discussing about the width, but now be careful. Our allowable tension, you see it's in is 2,75 Newton per millimeter width, so we're supposed to use the millimeters there. Your width, you put it as it is. Remember, there is 108 millimeter. Everything, use it to become, substitute as it is millimeter like this, multiply by the thickness, which was 5.5 was millimeter, isn't it? So multiply this, we know that is 2,75. Why are we doing this? Why? Remember this FT is what they say it is equals to mil per millimeter width. So these millimeters will cancel with other millimeters. We'll have with what this is Newton per millimeter. When we cancel, we'll be left with what, with newtons. Imagine multiplying millimeter like this. Picture as you're multiplying, you have a millimeter. Then you multiply this millimeter by Newton per millimeter. I said per millimeter with this, and that will cancel, will be left with newtons. So T1, because where T1 is measured in newtons, if we press this, sum up this guy, will be 966,25 Newton. This is what we have there, is T1. Now how, yeah, we have the angle of rep. Do not forget again, the angle of rep is, okay, we'll discuss about this because now I have TC, guys. There's a nice formula that I've discussed on my introduction video, that I've shown you the formula. I've shown you the different types of the formula to calculate power. There are lots. I think we have how many? I think we have approximately 6 formulas. We have 6 formulas, but then here, what we'll use according to what you have. There is this formula, T1 minus TC 1. There is this formula, T1 minus TC, right, into 1. Remember, into 1. Over 1. Then obviously this is BE, coefficient of friction, the angle of rep. Then we do like this, multiply by the velocity. Yeah, we have this, but because we have also this thing, the efficiency, you can include your efficiency. So we have many typical question. There is this one again that we are used to. The one says T1 minus T2, you have to multiply by velocity. You can also multiply by efficiency because you're given efficiency. But if you're using this one, we're supposed to know that how can you get T1 and T2? You're supposed to use this the basic one that we know from N4. Supposed to use this equation. And then if we can use this equation, you go about manipulating, you substitute TC, substitute T1, you get T2, then you substitute there. So yeah, it's up to you which one you prefer, guys. As I've said, I've just used this one there. Let us use the new one there, but use enough that you're suitable with. T1 we've calculated, we got 1966.25. TC it was 1258.66, then into 1 minus 1 over E, coefficient of friction, it was 0,1, it was 0,31, isn't it? So let me bring this down like this. So there we have minus over 1, we have E 0,31, but theta, what will be theta? The angle of rapt. We've given that, what was the reduction? 160, but it must be in reds, but that was in degrees. Will be sorry about that alarm. To convert to reds we'll divide this angle by 7.3. You get me? Then this will be 2,9, you know, 2,793. Remember, our angle is in rads, right? So we have that is equals to multiply by what? 2,793 all over like this, multiplied by the velocity, which was 28,3. Yes, then we multiply this again by the efficiency. If we multiply all of this again by the efficiency, multiply this by the efficiency, which was 75. As you have seen, this is same as 0,75. Then now it's a matter of pressing the calculator there. Then the output power that we'll have will be 15 times 10 to the power of 3 watts. But if we want this to be in kilo, it can be in kilowatts if you want this. So this is what it is. But you can use another method. Let's say you prefer to use the formula that we are used to. We are going to say T1 minus TC over T1 minus TC T2. Then will be equals to EU theta. T1 we have, it was 19,66,25. TC was 744,8. T2 we don't know. TC is still 744,8. It's equal to E, coefficient of friction is 0,31. Let's say I'm using another method. Let's say you wanted to use this method, which is fine, no problem. Remember, this is the final answer, guys. Here I'm just using, if the other candidate might prefer, let's say maybe you prefer this, you can still use this. then you do your things there on top. If you subtract there, get 1 2 2 1 1 2 2 1 comma 4 5 there. We have T2 7 4 4 comma 8. Then also punch that 2,377. Then it's a math multiply there, cross multiply. We have 221,45 will be 2,377. T2 minus multiply by that should be 17039. Then you're supposed to make T2 the subject. T2, if you make T2 the subject, will be 1221,45 minus plus, you take this to the other side, will be 1770,39. Then you divide by this guy, 2,377. Then yeah. Wow. This is T2. We want the power using the formula that we're used to. T1 minus T2 multiplied by velocity, but we have efficiency multiplied by the efficiency. Remember, actually this guy, remember to explain for you, actually this, remember guys, here is the formula. Do you remember? Efficiency. I want you to check something. The output power is equal to input power. Input power. Alright. It's an efficiency multiplied by what? By 100. What is that? It's equals to, efficiency is equals to this. Output power over input power. So guys, this is what I've did here. This formula, actually this formula is for input. Guys, this is for input power. We have T1 and T2. That is an input power. So do not, maybe someone, maybe get amazed why I've multiplied by this. How come it's like this? How come it's like that? So this is an output power. Remember, we have the efficiency. We want the output power. But the input, let me substitute that equation, T1 minus T2 multiplied by velocity. We know the power. Right, here we have 100%. So I want to make output power the subject. I will multiply there. Will be T1 minus T2 multiplied by V. Will be multiplied by what? By the efficiency. As you can see there, we have P out multiplied by this 100%. So if now, because we want to use the efficiency, we'll use it. You can, because now we'll use the efficiency as 0.75. If you use it as percentage, 75%, you will consider this. But because now we'll use it as this, we've converted it. This will be the same as 100 over 100, then which is 1, whereby 1 has no effect here, whereby 1 has no effect. So that is how I got this formula. That is why I'm saying power will be equals to T1 minus T2 multiplied by V multiplied by coefficient of the efficiency is this. Yeah guys, do not be amazed or stuff there. So T1 we have, so we know that T1 it was 966,25 minus T2, the one that we've just calculated it now, multiplied by velocity, which was 28,3 multiplied by the efficiency, which is 0.75. So punch this, you get 15,000 there watts. Then this will simply like, yeah, no, it's the same as times 10 to the power 3 watts. Then P will be 15 kilowatts. So yeah, guys, efficiency is equals to output power over input power multiplied by 100%, like this. So yeah, so thank you guys for watching. Please do not forget to subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Feel free to share this and to comment and share to your fellow classmates. All the best.